So next is going to be Giacomo Landeschi. I'm glad and proud to say that what I see, actually, I've been discussing this with Marco, but I can see it through the lines of this program of today. What we're witnessing here is the sort of creation of a micro community. I mean, there was already a community of people interested in digital archaeology, but this is a micro community which I would like to somehow define the community of the diaspora. It's mostly Italians abroad and some Italian who's in the homeland. So Giacomo Landeschi is one of those. He's an associate professor at Lund University, and he's been doing wonderful things there together with the Lunto. And his talk is about challenging the paradigms of site documentation, high definition versus multi-resolution approaches. So thank you, Giacomo.
Morning, everyone, and thank you, Andrea, for the introduction, and thank you, Marco, for inviting me to this very stimulating workshop. I'm really pleased to be here today, and I think this is a good opportunity for all of us to discuss about the different issues related to the use of digital technologies in field archaeology. So I will start my presentation trying to address some methodological and theoretical aspects related to the use of digital technologies in site documentation. Before doing that, I would like just to spend a few words about the Digital Archaeology Lab at Lund University, some just advertised. This is a lab devoted to the use of digital technologies applied to archaeological research in a very broad sense. And we started as a research group almost 10 years ago, together with my colleague Nicola Del Lunto. And then the research group became a real lab infrastructure. So nowadays is a proper infrastructure where we host researchers and doctoral students, and we set up a community. We were talking about the community, and this is the very idea that we have behind our lab. So our mission is not just to do research in digital technologies, digital application, but it's also about doing education, providing education. We have a master course in digital archaeology and structuring 2 modules in GIS and virtual reality or 3D data recording. And of course, we are very much committed to communication and analysis of the archaeological data. So we are constantly trying to push the boundaries of the methodology and try to adapt the methodology to the research questions that the different researchers that are part of this community want to ask. In terms of areas of expertise, we are covering 3D modeling, virtual reality, Web 3D. So we are covering different areas. We are not, of course, expert of everything, but we are very keen to open the lab to collaboration at national level and international level. So in this sense, we also learn from our interaction with other colleagues from other departments and other universities as well. Okay, having said that, I should have taken the time because I'm okay. Don't want to take too much of my 20 minutes. So just want to start by discussing the use of the term model, because model in archaeology is a term that is ubiquitous.
Sorry to interrupt you. It seems to me rather complex yet. I mean, we are a digital community and we can't make that.
Let's start. So let's go back to the definition of a model, because model is a term that is commonly used in archaeology. There is a long history of model and modeling in archaeology that goes back in time to the processual school, of course. But what is a model? We should reflect on the meaning of the terms that sometimes we use, we tend to use a bit uncritically in archaeology. So if we take this definition provided by Locke in his book on computer in archaeology, 2003, model is a simplification of more complex phenomena made to enable understanding. So we basically want to use a model to make it easier for us to understand certain phenomena that we want to represent and investigate. When we think about models, when we think about 3D models in archaeology, we think about something that is intimately related to computational archaeology, computational tool, computer graphics. But this is not completely true, because modeling as a practice in archaeology goes back in time long before computers were invented. So we have examples of physical 3D models that were made for the purpose of doing archaeological documentation. So as the example of the cork model of Pompeii. This is a physical cork model that is now at the Museo Archeologico Nazionale di Napoli. And this model provides a representation of the archaeological space of Pompeii that provides still today invaluable information about the state of preservation of the wall paintings, for example, a few years after the excavation was conducted. So we still rely on this model as a source of information. Let's see. For understanding the characteristics of that context at that specific period of time. But models were also used, 3D models, physical 3D models were also used to provide a representation of field excavation context, as it's illustrated by the models done by Pitt Rivers excavation conducted in England early 20th century. And these models provide representation of excavation area and provide information that is useful to understand the context where the investigation was conducted. This is just to say, this is very popular image used to represent an archaeological stratigraphy. This is just to say that when we think about 3D models, we think about object tools that are made for coping, for dealing with representation of something that by its very nature is three-dimensional. So archaeological stratigraphy is something that is is defined by three independent x, y, z coordinates. And as such, archaeologists have always tried to cope with the representation issues connected to the three-dimensionality. Okay, but the next point of this discussion is what is the real purpose of making 3D models in archaeology? What is the real need for us as archaeologists to use three-dimensional models in that representation? And I think this is a good discussion that goes back in time. Already in the 90s, scholars pointed out they discuss and question the role of three-dimensionality, virtual reality for its use in archaeological data representation. And in particular, one of the main criticisms was that virtual reality should have not been just used for imitating the reality of the context under investigation, but should have been used for doing something more than just having a mimetic purpose. So this is to say that our attempt was to try to combine 3D models and analytic tools provided by geographical information systems in order to try to cope with these problems of the inadequacy of virtual reality or 3D data representation for answering specific archaeological questions. So, and why combining 3D models with geographical information system? Because geographical information system, as has been already said in the previous presentation, is an extremely powerful tool for analyzing geospatial information. And since archaeological information is geospatial information, it's important for archaeologists to rely on this tool for investigating an archaeological landscape, an archaeological space. And the main problem when it comes to GIS, of course, is that there is still a problem of lacking in the possibility of coping with the complexity of the landscape of the archaeological context representation. As has been pointed out by Lovera in this article published on Journal of Archaeological Method and Theory in 2012, the problem of GIS data representation is that just by relying on the traditional vector primitives, point, line, and polygons, it's not possible to cope with the complexity of the space that we want to investigate. So our choice to combine and to experiment the use of three-dimensionality, 3D data representation in GIS started from this reflection. So trying to take the advantage of 3D multidimensional representation of the data and combining this with the analytic potential provided by GIS tools in order to rely on an instrument that could allow us to extract more information from the archaeological context under investigation. So, and then we move on to the next point, that is one of the main points of this presentation. So the discussion about the need of having high definition data and the possibility of questioning this high definition approach by replacing the term high definition with a more possibly appropriate definition that is multi-resolution approach. Why did I start with this comparison? Because I noticed that there is a vast literature discussing and introducing the term high definition archaeology. It's become very popular in recent years because of the widespread of big data and innovative acquisition techniques. But actually, the term high definition was first introduced in the 90s. So to define a methodological approach in which the archaeological record is investigated with significantly high level of detail. So we can define definition in terms of number of intervals in which you can decompose natural or artificial phenomenon in order to make this phenomenon more clear to understand. So we can use a synonym of clarity to replace the term definition. The typical example, if we take digital photography, is given by a high resolution image that is represented by a higher number of sampling intervals represented by the pixels. So, of course, the result is that the image represented is more clear. But to go back to the question, do we really need to have a high definition approach, or we should rather rethink this and talk about multi-resolution approaches? The question is, one of the possible answers for me is that targets make the difference. So depending on the scale, of course, of your analysis, depending on the research questions that guide your project, you might want to use a certain type of data set. And even though this data set is not a super accurate, especially accurate data set, it might be sufficiently enough to detect a certain class of archaeological features. So this is an example from remote sensing. So if you take, for example, a LiDAR-derived digital terrain model, and you want to investigate the presence of religious buildings, for example, in a woodland. Here we are in Blera, in central Italy, and it's sufficient probably to use a DTM with a resolution of 1 meter, spatial resolution of 1 meter per pixel. But if we look closer and we analyze the same space, the same portion of space with a data set with a higher level of spatial resolution, up to 10 centimeter per pixel, we might be able to define more details that correspond to additional classes of archaeological features, in this case, some burials. In the space of this abandoned church. And if we integrate this information with additional data set derived from different acquisition methods and techniques, we probably increase our understanding of the context. And here we go with the definition of a multi-resolution approach, where it's not just the spatial resolution that gives us certain type of answer, but it's also the radiometric resolution, for instance. So the number of color gradient intervals that you can have for representing the reflectance in a raster image, or the spectral resolution, the number of spectral bands that are associated to the sensor that has been used to acquire information about that specific context. So this is just to say that we should rather talk of an ND-GIS rather than 3D GIS. So we should completely revise the title of 3D GIS, because I think ND-GIS would be more appropriate to define this particular approach that combines different types of resolution, where the resolution is not just the spatial resolution, but is also the temporal resolution that defines number of temporal intervals that can be presented in the GIS project. The source resolution that indicates the number of data formats that can be handled in a GIS space. And the analytic resolution that also includes all the possible analytic tools that can be used in combination with GIS. So This is a critical aspect that, to me, is characterizing state of the art in GIS-based application. Okay, very briefly. I don't know how many minutes I still have. Probably very few, but I will try to be as fast as possible. And this is just a case study that I want to use as an example for describing this multi-resolution approach, and in particular to describe the possibility connected to the use of 3D.
Scusa, ma no, non si vede questa diapositiva.
Okay.
Adesso sì.
Okay, so I will keep pressing the button. But this is just to describe the possibility connected to the use of 3D model and 3D modeling in the context of an archaeological investigation of stratigraphic sequence. This is a research project conducted a few years ago in the small island of Stora Karlsö. There is a small island south of Gotland Island in the middle of the Baltic Sea. This is an important site for prehistorians because there is an important cave that was investigated in the end of 19th century. So here we are dealing with legacy data. We are dealing with data that were produced in the frame of this excavation that was conducted at the end of 19th century, and whose excavation reports were produced just 40 years after the excavation was conducted. So we were dealing with a lot of information that was collected through the years, and we didn't have access to the original information provided by the excavation, but through the excavation record, it was possible for us to understand information about the original disposition of the spit layers in which this sequence was excavated, and information related to the different spit units and the classes of artifacts and ectofacts that were recovered in this context. So by combining this legacy data, it was possible to reconstruct the sequence as it was viewed by the excavator in the end of 19th century. We use this as a geometrical reference for reconstructing the different spit units, and the plan was used to provide information about the outermost boundaries of this sequence. And of course, we scanned the cave so that it was possible to have the outermost boundaries of the sequence and the three-dimensional boundaries of the sequence. In this way, it was possible to create a sequence of three-dimensional shapefile, volumetric, as a boundary models, and to connect each one of these original spit unit with the information that was originally stored in this historical archive. So we know exactly how many hard seal bones were associated to each unit, or how many pottery fragments were associated to these units. So the real advantage of this approach was the possibility to connect this information with database entry and to create some density maps, three-dimensional density maps that provide us with invaluable information about the different phases of inhabitation of the cave. So it was important for us to use this information to reconstruct the relative chronology of the cave and to understand, based on the distribution of the different chronological indicators, what was the Mesolithic phase of frequentation of the inhabitation of the cave and when it ended. We combined this information with absolute chronological indicators that were extracted from the wall of the cave and that were georeferenced into the space of the three-dimensional reconstructed cave, so that it was possible to combine their position with the position of the reconstructed sequence in order to validate the information provided in terms of relative chronology. Okay, so I will go to the conclusion. We use also historical images of the cave, and we georeferenced some of these historical images in order to get additional information about certain layers, and for example, this is a difference in the color of the layers that indicates a hiatus in the inhabitation of the cave that corresponds to the boundary of the Mesolithic phase of inhabitation of this cave. So this was an additional indicator that we combined with the previously collected data. And as a final result, we were able to define the chronology of the sequence that corresponded to the Mesolithic phase of inhabitation. That was because the main question related to this project that was done in collaboration with the prehistorians in our department was related to the distribution and of the different chronological phases, and in particular the study of the chronological phase connected to the Mesolithic part of the navigation of the cave. And as a result, of course, we published this as an article, and it was important for us also to reflect on the role of legacy data and the reuse of archival information in order to extract some information that can be used for the analysis of the archaeological context. And of course, based on the recently established United Nations sustainability goals, this case study was a sort of example of how to promote a responsible use of data sources, in this case digital data, that can meet the expectation of these United Nations sustainability goals. And here, of course, there are some references. Yeah, I mean, that's all.
Thank you.